The KAAN fighter jet is Turkey's first attempt to develop a fully indigenous fifth-generation fighter capable of competing with modern stealth aircraft in terms of speed, maneuverability, survivability, and sensor integration. The aircraft is being developed by Turkish aerospace industries under the TFX program and represents a culmination of years of research into advanced aerodynamics, stealth technologies, electronic warfare, and avionics systems. The design philosophy of KAAN prioritizes low observability, high agility, and multi-role operational capability, which means it is being developed to perform air-to-air, air-to-ground, reconnaissance, and electronic warfare missions. The aircraft's structure incorporates radar-absorbent materials and shaping that minimizes radar cross-section, while also including internal weapons bays to reduce radar signature when armed. The first prototype of KAAN successfully flew in February 2024. This flight demonstrated that the Turkish aerospace industry had reached a level of precision engineering and systems integration necessary to produce an airframe capable of controlled flight, stability, and handling in accordance with fifth-generation standards. The prototype phase is critical, as it allows engineers to test aerodynamics, flight control systems, stealth performance, and integration of avionics and sensors before moving into serial production. The development process is phased, with multiple prototypes scheduled to incrementally test new features, progressively integrate advanced systems, and refine the aircraft's performance. The aircraft has been designed to eventually operate with an indigenous turbofan engine, the KAAN 35000, which is being developed concurrently. The engine represents one of the most technologically complex components of the program, as it must provide high thrust, reliability, and efficiency while fitting within the stealth and aerodynamic requirements of the aircraft. Engine testing and prototype integration are ongoing, and the completion of this phase is essential before serial production can begin. The KAAN 35000 is intended to be fully developed, tested, and ready for production within the next few years, providing the thrust and operational characteristics needed for a modern fifth-generation fighter. The integration of this engine will also involve testing for stealth compatibility, thermal signature management, vibration minimization, and software integration with flight control and avionics systems. In late 2025, Turkey extended an offer to Pakistan to participate in the KAAN program, which marks a significant step in international cooperation for the aircraft. The proposed partnership involves joint production, where Pakistan would host facilities to manufacture or assemble components of the aircraft. This includes potentially producing parts of the airframe, assembling avionics systems, integrating electronics, and participating in testing and quality assurance processes. Pakistan's aerospace industry, including the Pakistan Aeronautical Complex and affiliated entities, would be central to this collaboration. By participating, Pakistan gains not only access to fifth-generation fighter technologies but also experience and capability in advanced aerospace manufacturing and systems integration. This would help Pakistan move toward greater self-reliance in defense technology and potentially allow for upgrades, maintenance, and eventual indigenous production of aircraft. The partnership is intended to be deep and strategic rather than merely a customer-supplier relationship, allowing for technology transfer, skill development, and industrial participation at multiple levels of production and design. Alongside the fighter program, discussions have taken place regarding the establishment of a drone assembly or production facility in Pakistan. These drones would likely include high-endurance unmanned aerial vehicles capable of reconnaissance, intelligence gathering, and potentially strike roles. The integration of both manned and unmanned systems into a single collaborative framework demonstrates a long-term strategic approach, combining fighter jet capabilities with advanced unmanned systems. This approach provides Pakistan with a broader capability base, enabling flexible responses to operational challenges while simultaneously fostering the development of a skilled workforce and an advanced industrial base. The drone component complements the fighter program, as the technologies involved, such as stealth materials, avionics, sensors, communications, and flight control systems, overlap, allowing both countries to leverage the same research and development resources. The potential benefits for Pakistan are substantial and multi-layered. Access to KAAN's technology would include exposure to radar-absorbent materials, stealth coatings, avionics systems, electronic warfare systems, sensor fusion, and the integration of advanced engines. This could significantly reduce Pakistan's reliance on external suppliers for high-end aircraft capabilities, while simultaneously developing domestic expertise in areas such as aerodynamics, materials science, electronics, software, and manufacturing processes. The creation of joint production facilities would also generate high-skill employment opportunities, foster engineering and technical talent, and establish a long-term infrastructure capable of supporting future aerospace projects. For the Pakistan Air Force, the eventual integration of KAAN would provide a pathway to operational fifth-generation capabilities, supplementing existing fleets of JF-17 and F-16 aircraft, while introducing modern stealth, sensor, and electronic warfare capabilities that currently do not exist in Pakistan's inventory. Turkey's perspective on this collaboration is also strategic. By involving Pakistan, Turkey strengthens its position as a defense technology exporter, expands its international cooperation network, and creates a potential partner for future projects or exports. The joint effort also ensures that Turkey can leverage Pakistan's industrial and technical capabilities, creating efficiencies in production, testing, and potentially maintenance of future aircraft. Moreover, it positions Turkey as a leader in advanced aerospace technology in its region, demonstrating that it can not only produce fifth-generation fighters but also engage other nations in high-level technological partnerships. The potential for future exports to other markets is also enhanced when a partner country is involved in the development and production process, as it can facilitate broader industrial support and market access. While the partnership has been publicly acknowledged, no formal agreement, signed contract, or timeline for induction has been disclosed. Many aspects of the cooperation remain under discussion, including the scope of technology transfer, the exact production responsibilities for each country, and the division of work in aircraft assembly and testing. Other uncertainties include licensing and intellectual property arrangements, quality assurance standards, and long-term maintenance and support structures. Successful implementation will require careful management of these factors, as well as sustained funding, political stability, and coordination between engineering teams across both countries. Operationally, introducing KAAN into Pakistan's Air Force would require careful integration with existing aircraft fleets, training for pilots on a fifth-generation platform, and development of maintenance, logistics, and operational doctrines specific to the aircraft. Integration of the TATF 35000 engine, avionics, sensors, and stealth technologies into Pakistan's defense infrastructure would need to be phased carefully to ensure operational readiness. Pakistan would also need to develop systems for continuous upgrades, software management, and potential future modifications, which are key aspects of sustaining a fifth-generation fighter fleet. Strategically, the cooperation enhances the defense capabilities of both countries. Pakistan gains access to high-end fighter technology and advanced industrial capability, while Turkey strengthens its international presence and secures a partner for production and potential export projects. Joint development projects such as this also encourage long-term technological self-reliance, knowledge sharing, and the creation of a skilled workforce capable of supporting increasingly complex aerospace projects. The combination of manned and unmanned systems creates a layered approach to operational capability, providing flexibility in combat scenarios, reconnaissance, and electronic warfare. Challenges remain significant. Fifth-generation fighter production is inherently complex, requiring precision engineering, advanced materials, software integration, and highly specialized production facilities. Engine integration and testing, stealth coating application, avionics calibration, and structural stress testing all represent technical hurdles that must be overcome before serial production can begin. Financial requirements are also substantial, as the development, testing, and industrialization of a fifth-generation fighter involves multi-year budgets and the coordination of a large number of industrial partners and suppliers. Geopolitical factors, including regional dynamics and relationships with other defense suppliers, may also influence the pace and scale of the program. Pakistan's continued interest in other aircraft sources could affect its commitment to KAAN or influence the level of industrial participation. Progress can be monitored through several indicators. Signing of formal agreements would signal that preliminary discussions have transitioned to actual commitment. Announcements regarding the construction of joint production facilities or progress on the TATF 35,000 engine would indicate technical milestones being achieved. Flight testing of prototypes, integration of avionics and weapons systems, and testing of stealth features would provide evidence of the program's readiness to move toward serial production. Ultimately, the pace and scale of KAAN's deployment in Pakistan will depend on successful resolution of technical, financial, and operational challenges, as well as sustained cooperation between the two countries over multiple years. The long-term implications of this partnership are considerable. Pakistan's aerospace sector would gain knowledge, infrastructure, and human capital, laying the foundation for future domestic projects. Turkey would reinforce its position as a producer of advanced fighter aircraft capable of international collaboration. Operationally, the introduction of KAAN could transform Pakistan's Air Force, providing capabilities that include stealth, advanced sensors, electronic warfare, and multirole flexibility. Industrially, joint production and integration would establish a base of expertise that could extend to future aircraft development, upgrades, and export opportunities. The trajectory of the cooperation indicates a strategic effort to integrate advanced aerospace technologies into both countries' industrial and defense capabilities. The combination of manned fighters and unmanned aerial vehicles creates a comprehensive approach, enhancing both operational flexibility and industrial synergy. While much remains uncertain regarding specific timelines, production shares, and operational integration, the program is positioned as a long-term strategic collaboration that could redefine the technological landscape of both countries' air forces. Over time, successful implementation could allow Pakistan to participate in the ongoing evolution of the fighter platform, including upgrades to avionics, weapons systems, stealth capabilities, and engine performance. This would create a pathway toward a sustainable fifth-generation fighter capability that is supported by domestic industrial and technical expertise. The KAAN fighter program and the partnership with Pakistan represent one of the most ambitious collaborative aerospace projects in the region. It combines advanced stealth technology, indigenous engine development, avionics integration, and drone cooperation to create a multifaceted industrial and operational framework. The program's success will depend on careful coordination, sustained funding, technological development, and effective integration of both countries' industrial capacities. If fully realized, it could provide Pakistan with fifth-generation fighter capability, establish Turkey as a global defense technology leader, and create a long-lasting industrial and technological partnership between the two countries. The cooperation is a long-term project, expected to span many years and potentially decades, shaping both nations' defense and aerospace sectors for the foreseeable future.